Thanks everybody for coming. My name is David Wheeler. I am the creator of PGXN, the Postgres extension network. I currently work for Tembo. I've been there since the beginning of the year. I'm very happy to be working full-time on this again after an extensive interlude. I'm happy to be back here talking to you all about the future of the Postgres extension ecosystem. I don't stand on ceremony, so if you want to ask questions at any time or correct me, hey Devon, just feel free. So let's first, is this going to work? Yes, there we go. So let's first talk briefly about the history of extensibility in Postgres, which is long, right? Yeah, there we go. Initially, there were two approaches to doing extensions in Postgres without forking the product itself. One is to load dynamic modules into the shared preload libraries configuration to bring functionality into the database directly from a C library. And another was to use pure SQL, including procedural languages, to create stuff that you might need or want to do to extend the functionality. And there were a few intrepid adopters in this early period of extensions in Postgres, many of which you've probably heard of, including PostGIS, BioPostgres, PLR, PLProxy, PGTap, and a fair number of others, actually, which demonstrated the attractiveness, the feasibility of wanting to have extensions in Postgres. So in Postgres 9.1, Dimitri Fontaine worked up a patch and got it committed and released to add formal extension support to Postgres. The key features of this patch was support for compiling and installing your extensions, whether they're C or SQL. A sugar for creating, updating, and dropping extensions, where all the parts of your extension can be put in a single bundle that can be handled more or less as a single object. And PG dump and PG restore support, so that when you dumped a database, it would dump just the object, the create extension command, and not all your objects. So at that point, I was pretty excited about the future of extensions, and I said, you know, Postgres is not just a database, it's like an application development platform. And with that in mind, I decided to try to build an extension distribution system based on CPAN. I was a longtime Perl developer back in 2010. The features I wanted to provide were source code distribution, the ability for extension authors to register for accounts and also to register their extension names so they preserve their uniqueness in protecting them, and that's the name spacing is for extension names, modeling how they work in Postgres itself. Also wanted to provide discovery in the form of a website with good search of all the extensions, their documentation about the distributions, tags that are in them, and the ability to have full text documentation indexed and to be provided by extension authors so there could be nice documentation to show to users wanting to learn how to use the extension. And a third aspect was installation, where we were going to build a command line client that would handle kind of transparently the compile and install stuff, downloading extension, all that, putting it all in the right place, using PGXS or configure autoconf style installation pipelines. So with this kind of vision, I'm getting ahead of myself. So there were some things that were out of scope of my proposal. One was binary packaging. I felt it was best just to, for binary distribution, just to defer to the community apt and Yum repositories and just kind of stay out of that. Also, developer tooling. We already had build tooling for PGXS. And early on, people said to me, well, how are you going to build extensions? And I said, I'm not touching that problem. Core is defined this way to do it. That's the way you should do it. We're about discovery and distribution of the source code. So again, with that in mind, we started the project in 2010. I made this proposal. I had a little fundraiser to raise money for it. I was a consultant with Postgresql experts at the time, and we wanted to fund the time for me to work on it, raise the money, and started work on December 2010. I launched the site pgxn.org in April of 2011, and that was followed almost immediately after that by Daniele Varazzo, wrote the command line client, which was amazing because I had planned to do it. It was like next to my task. And he did it in Python. Yes, Python, which was cool because I was doing everything in Perl. It was nice to see that you could use whatever language you wanted to use the APIs provided by PGXN to do what you need to do. And a couple months later, I wanted to go backward, Dixon Guedes released developer utils that allow you to like create a new extension repository or to release it on PGXN. So that was cool. And I continued to work on it into 2012, and at that point I got busy with my day job. I had since moved to full-time employment at a corporation, and so PGXN kind of took a back seat. And I've only done the basic maintenance on it since then. It's hosted on Depeza's server in Germany, and he and I make sure it keeps running. And I've made some modifications over time, but for the most part, it hasn't changed much in 12 years. So as I like to say to my colleagues who've worked in these big corporations, in classic software development lifestyle fashion, PGXN, proof of concept, shipped as a minimum viable product, and was neglected. Just like all the best software in the world, right? So, time passed. So in the intervening years, I want to look at like what the uptake of extensions have been. Today, or as of a couple days ago anyway, there are 396 extensions on PGXN in 369 distributions. This is because some distributions can have multiple extensions in them. Meanwhile, Joel and SQL has created a list of all the extensions that they could find and put it in a gist on GitHub and found almost 1,200. So there's a lot that is not on PGXN that is publicly available. And meanwhile, CPAN, on which I based the design of PGXN, as of a few days ago, has 45,000 distributions. PyPy has over 500,000 Python projects, which is astronomical. I was kind of shocked by that. Ruby Gems has 180,000 gems, and crates.io, the Rust distribution system, has 146,000 crates. So we got to thinking, why is it, what the hell was it with these buttons? Back. Why is it, don't push the button, David. Why is it the uptake for some of these other projects has been so enormous? Granted, some of them had a head start, but like Rust didn't, and Go also has a huge number of packages, and they weren't even around then. While PGXN has sat with, at best, 400 extensions, and even in the overall Postgres community, there are maybe 1,200. This is a tiny fraction of what others do. Well, I think in the intervening time, there have been some lost opportunities, right? Despite the best intentions of some people, it's difficult to find and discover extensions because there is no one place to go. If you're interested in extensions, you have to know A, you're interested in extensions, B, what you're interested in, C, where to look, which includes PGXN, GitHub, Trunk, PGXman, DB.dev, the apt and community apt and Yum and apt repositories, GitLab, Bitbucket, you name it, right? It's just all over the place. And then even when it is available, if it's on PGXN or something like that, most of them are under-documented and difficult to understand. So you might find something on PGXN, but it just has a README for how to install it and maybe a single line saying, here's the function to use. And is that sufficient? The extensions you find, the maturity can be difficult to gauge, right? You don't know necessarily like how long it's been around, how much effort was put into it, especially if there's not much documentation, although that's a bit of a signal. There's no rating system, there's no count of downloads, there's none of that stuff to give you a sense of how good it is, unless it's been specifically picked up by the packaging system you trust. So like the 200 that Devram has put in Yum, you probably have a good sense of, but pretty much everything else, hundreds and hundreds of others, who knows? it remains difficult to configure and install, especially if you're an end user and all you want to do is install the damn thing and get started with it. It's like step one, install a compiler on your production web server. It's like, or database server. It's like, what? No, I just want a package. Again, if you have the packages in the package systems, that's great. But for everything else, what do you do? And so there's no comprehensive binary packaging. Everybody who's done binary packaging just has a subset of extensions. Come on. Did it go backwards? It's going backwards now. Awesome. Oh, okay, left mouse click is on the left even though I'm going forward. Okay. So the conclusion I reach is that centralized source distribution is insufficient, which is what PGXN attempted to do, is to be the one place where source code for extensions was distributed and findable. And there's insufficient developer tooling to help developers to improve this situation, to get things to the right places, to know how to get things going. But as I said, things haven't stood still, and a number of projects have emerged in the last couple of years in particular that try to fill some of the gaps in this. One is db.dev, which is a site on database.dev where they distribute trusted language extensions, or TLEs, through the PGTLE project. This is cool because if your extension is a trusted language extension, in other words, there's no shared library module to install, it doesn't need access to the file system. If you have your project on db.dev and you have db.dev extension installed in your database, you can literally run an install function in the database and it will fetch it from db.dev and install it in the system for PGTLE to use, and then you can just use create extension to use it. Which is, I think, a really interesting development. Now I know how to go backwards. Another one is Trunk, right? Created by my erstwhile employers. Is it erstwhile? No, they're just my employers. Last year, before I joined the company, it's hosted at pkg.go.dev, and they provide packaging for over 200 extensions. And today it supports AMD 64 Linux. Another one that came out in the last 6 months or last 4 months is PGXN from our friends at Hydra. It's kind of similar in vision for Trunk, but they provide DEB packages for the distributions. So what's interesting about these projects is they have emphasized, in some respects, different things from what PGXN has. For example, one is ease of use, as in this example from PGXman, where they have a single command to install PGXman itself, and then a single command to very quickly install the binaries you want. Another one is platform neutrality, where they want to actually create binaries to distribute to multiple platforms, as in this example here from Trunk, where they show you this is the architecture on which you can run this. Statistics. PGXN has no statistics, but db.dev gives you numbers of downloads that are for something, again, to help get at that signal that's been missing. Curation is another one. This is one of the more popular aspects of Trunk, where the maintainers have created categories that they put all the extensions in, and so people know, like if they know I'm interested in a specific use case like analytics or metrics, they can go to that category and limit kind of what they're looking through to find what they need. Now, the thing about all these projects is that somewhat like PGXN, they're like minimum viable products at this point. So Trunk, for example, in order to get something in Trunk, you need to submit a pull request. It currently supports only Postgres 14 through 16. It's Debian and Ubuntu only Linux. Currently only AMD 64 and 210 extensions. Now there are plans to add, other operating systems and ARM64 and stuff like that, but that's hasn't happened yet. Why is it doing? I'm going back here. Oh, it's just doing that. Fine. PGXman has form-based submission. If you want to add your extension to PGXman, they have a form you fill out and submit. I don't know how that works. They support Postgres 9 through 12. Also Debian and Ubuntu only, and then only app packages. An interesting thing about Trunk is that their packaging is not packaging specific. It's just the binaries are in there and it knows where to put them thanks to pgconfig. PGXN is like, we're basing it on the community app repository, and these are things we're layering on top. They currently have, by the count that I could figure out on their website, 81 extensions. And db.dev, as I said, is only trusted language extensions. You can publish there with their CLI, which is cool. They support all the way back to Postgres 11. No C or PGRX, so there's no AMD ARM64 that's irrelevant for their stuff. It depends on your having the PGTLE and what is it? I misspelled that, PTSQL. I think it's PGSQL HTTP extension, because again, it's pulling extensions over HTTP from db.dev to install. And I don't know how many extensions are on there. I couldn't figure out how to pilfer that information out of it. I'll have to find the Superbase folks and ask them. So what's the state of affairs at this point? And all these recent developments have kind of invigorated, I think, the broader extension ecosystem. But many of the promises we saw early on that, Dimitri and I talked about, like as far back as 2010, have yet really to be fulfilled. So just to summarize, there's no single source to find extensions, although there are many incomplete attempts. There's poor discovery and difficult installation, especially if you're an end user who just wants to get the binary and go. There's insufficient documentation for a lot of extensions, or figuring out how to use extensions or how to build extensions, and therefore there's been relatively low adoption. I think the number of databases that use extensions is very, very low, and those that use more than one or two, outside of core in particular, is except for something like PostGIS and maybe increasingly PG Vector, is quite low.
Where did you get that stat from? Like how low it is?
One of the members of the team did some research on that at some point, right?
I think there's some confidential context I have, which I would not be sharing. But
okay, got it.
I used to work at Microsoft at one point, and I know roughly what the number was there on Azure. But there was also like a bunch of kind of surveys we've done around at multiple events and stuff, asking people how many.
And you said the number was 2. What did you say the number was?
Well, I'm basically my answer is Samai told me, but my understanding is that it's really low.
So I think like I've asked this question at multiple conferences and stuff. Like I think I've heard like less than 1 or 2 people say greater than 5.
Yeah, how many of you use more than 2 extensions? How many use more than 3? Yeah. So those, you either use extensions or you don't, basically, right? Yeah. But yet, at the same time, there sure has been a lot of excitement about extensions lately. And the emergence of all these new binary packaging registries really highlights that for me, as well as PGTLE itself really trying a different approach, and the PGRX project, which is really kind of bringing even more people into the fold, being excited about building Rust-based extensions. So let's talk about the new opportunities. We've launched a project this year we're calling PGXN v2, as more or less a code name. This is thanks again to Tembo, who hired me to work on this as a project in a way I have not been able to for the last 12 years. The responsibility is to kind of consider these emerging patterns and the problems they're trying to solve, to meditate on the deficiencies, some of which I've talked about here, and to engage deeply with the community to try to imagine what our idealized extension distribution system of the future would look like, and to design and implement a new architecture to serve the ecosystem for the next decade. So the first part of that, engaging with the community deeply, is I've collaborated with a number of other people, including Jeremy, who's here, and a couple other folks on something we call the Extension Ecosystem Summit. Many of you, I think, were there earlier this week. We actually had 6 mini summits over 12 weeks leading up to it, in which we had people come in and talk about various topics, and then we got involved in the discussion. So there was just like an hour every couple weeks in which we, somebody would talk about particular issues, and then we'd discuss it afterward. Videos are up on that on the Tembo YouTube channel, and on my blog I have notes for all of them, detailed notes, more than you ever want to read. So, but this leads me to the question of what exactly, or who, I should say, is the ecosystem. When I say the future of the extension ecosystem, who are we talking about here? So I'm putting it into a number of categories. One is extension authors, which I think probably many of you have been. The needs of extension authors include tools to create extensions, learning materials like so that you know how to get started with extensions, you know what references there are to build things. Standard patterns for different kinds of extensions to get you started, and testing tools to make it easier to test your compatibility, different operating systems, different platforms. There's metadata management, not only the control file that's required for create extensions, but also metadata for systems like PGXN with its meta.json file, or trunk with its trunk.toml file, and there are a couple others. Distribution and discovery, to be able to say, I've released this extension and have it go out in a place where people can find it and discover it. So we're aiming to address these needs for extension authors in a number through this effort. One bit, of course, is documentation, where we want to work on and recruit people to contribute to how-to documents and examples and tutorials and references, or maybe write a book. I mean, it's one thing I've learned talking to a lot of people here is there is a lot to extension stuff. You could have a whole book about this stuff. That would be a great reference for people. We want to create a command line client or update the existing client to allow authors to more easily manage the metadata for their extensions, to manage testing across platforms and Postgres versions. Scaffolding and templating to add things to your extension source code. Commands to release or to scaffold documentation. And tools for continuous integration and continuous deployment. And then there's the canonical registry, which enables the discovery to the search, and to extend that from the source code-based distribution of PGXN to also binary distribution and packaging. Perhaps something with category curation inspired by the trunk stuff to make it easier to find things that fulfill particular business cases. And then also create incentives for extension authors to make their lives better and make their extensions better, including things like quality metrics that you can improve upon to make your extension easier to discover, better tested, what have you. Documentation standards, I really love to figure out how we could standardize in documentation as opposed to right now where if there is documentation, it's kind of ad hoc and all over and people use 20 different formats. And test coverage and matrices. Years ago, Thomas Vondra created a matrix for testing PGXN distributions on a bunch of versions of Postgres and publish it as a matrix, and that can be really useful for people, especially if they're unable to do the CI/CD stuff themselves to do coverage, to see it published there, and then it becomes a signal for others. So I have a couple of mock-ups here for what some of the tooling might look like. So let's say you're an extension author and you want to manage your extension. So let's see, first we get a list of what installs we have locally, because extension developers, we probably have a bunch of them. So the tool I'm proposing here can give you a list of all the installs in your systems. This is showing you we have one from Homebrew, a couple from PGM, one is the Postgres app itself. And as here for PGM 16.3, it shows you the root directory where it lives. So let's say, all right, let's manage that particular install and see what's there. So with that in place, we can say, all right, let's develop a new extension. I'm going to call it Bike. It is, I'm going to write it in C. It's going to live on GitHub. Excuse me. And it can just write out all the files to get you started, right? So for a C extension, you're going to have your PGXN metadata, your control file, the make file that uses PGXS, and a start of a README. Go back. There. The source code that you need, including the C source file that you're going to start with, the SQL file that's going to have the commands to create it, and start a documentation document separate from your README to encourage people to write good documentation specifically for your extension. Test files for test. In this case, following the C PGXS pattern, we have PGRegress-based testing. And then some workflows for you to use on GitHub to do CI/CD across versions of Postgres on various platforms, ideally, but even if it's just Linux to start, that's a good place to start. And to release it on PGXN when it's ready to go. Now, I'm imagining we can add all sorts of features to the develop CLI to do various tasks, like let's say, okay, I need to add an upgrade from 001 to 002. So it can go ahead and do that by copying, let's see if I have, no laser. Copying the existing 001 file into 002 and then creating a file that for migrating from 001 to 002. This is the pattern that alter extension update uses to upgrade extensions, is this file naming convention. And then we update the meta.json file and the control file with that information. Similarly, you can use it to declare the dependencies you have. So it could say, okay, we want to require Postgres 14. So then it would update the meta.json file for that. Or we can say, we want to require another extension, in this case, semver version 0.32.0. Again, it's updating the meta.json file and also the control file. So to try to, take away some of the busy work of maintaining some of this stuff, and trying to remember where all the places are you need to deal with it, have it in one place in the CLI to help you with that. Now let's, we could extend this to actually helping you with to really test your extension and to build it and all that. So if we have a PGXN develop test command, it can actually have these subcommands that run. I mean, you can also have PGXN develop make install, and install check, but here it does them all at once, just like the make file would. So it says I'm testing against this particular install, this pgem 16.3. Here's where it's compiling the source. Here's where it's copying the files to where Postgres is going to be, and here's where it's running the regression tests. Now, a lot of us do this just with the make file, but it'd be nice to have this here so that maybe you have the same commands and it works with PGRX-based ones. Maybe it works with Python-based extensions. Maybe you have, your NPM-based extension or what have you, to have it because it knows how to get those things to talk to the Postgres in a way that is effective. And of course, it can be used for releasing the extension. You just tell it to release it, and it will bundle it. It'll make sure everything's valid, and it'll push it up onto PGXN for you and publish it and tell you where to find it. So in addition to the command line tools just to help you in your iterative development process as you're building and working on and testing an extension, we want to provide tooling for CI/CD so you can have it in your GitHub workflows or whatever workflow pipelines you want to use to test on a bunch of versions of Postgres, and to do the release on PGXN, or maybe even, I have projects here that do, release it on GitHub as well. So again, that stuff is scaffolded out by the command line client, and it's just there on the repository. And this helps you make sure that you're maintaining the quality of your extension and releasing it in a way when you tag it for release is automatically released. This, by the way, these screenshots are from projects that are using a Docker container I've written in the last couple of years to automate all this. So you have to integrate that into your existing extension repositories, but we wanted to make it so that the command line client can kind of take away the grind of managing that stuff. All right, so that's extension authors. Who else we have in the ecosystem are packagers. These are people who take the source or binaries that they find for extensions, and they package them for various platforms, operating systems, Postgres versions, what have you. So what do they need? They need to know when there are new releases of extensions so that they know to update them. This is because almost always the person who maintains the extension does not maintain the operating system packages. So the packagers need some way to be notified. There's a new release so that they can go and update this stuff. Ideally, they could get to a point where they're comfortable with it or they have some sort of approval process where they could automate some of this stuff. So when there's a new release, they can be notified and just do a build and publish it or work it or put it in some sort of approval pipeline. They need predictable download URLs to do that. So when you know there's a new version, you know where to pull it from. And flexible sourcing. So some packagers may want to use precompiled binaries to put in their package. I think Homebrew often does stuff like that. And other ones like the community apt and Yum repositories actually want to download the source and build from source. So they need the flexibility for that. In order to do any amount of real automation, they need extensive metadata. This is particularly true if you have third-party dependencies, like I think of PostGIS is the poster boy for this. It has a whole bunch of external dependencies. It'd be useful to be able to declare those as an extension author in your metadata so that these packaging systems can see it and know, okay, we need to install this and include this as a dependency through our RPMs or DEBs or what have you. And there's feedback loops. It's like, well, the build on this release didn't actually work. How do I let the author know that, right? How do we let the community know that? And can we maybe submit additional statistics that some of these systems may not be able to do, like number of downloads or number of installs or number of failed installs, number of failed builds, etc. So to meet these needs, some of which I'm projecting and Devram will correct me on, what we want to build are release feeds and notification webhooks. This is a system where we can publish RSS or Atom feeds for releases of things, but also potentially have a system, a webhook system where we could have subscribers who would just have a service that's listening and get notified immediately upon release. This will allow them to package automatically on every release and build from source or repackage the community binaries that we like to build. Again, we need the metadata to automate the building from source, so we need to expand on the sort of metadata that we have today with the PGXN metaspec and maybe combine it with other specifications. And a system to be able to report back build failures that then will get to the author, but also show up in a place where users can see it and say, oh, this release actually doesn't work on my OS, so I'm going to hold off trying to upgrade. And again, as I said before, some of them may have statistics that they could share as well that will come back and then be aggregated from many downstream packagers on the core site for the system. So here's an example I mocked up of like an RPM spec file and how it might work. So first of all, we have a, why does it, I keep double clicking these. Yes, a predictable URL for where to get the new release, a new version. They could potentially also, we might have a package subcommand of the PGXN client that could be used specifically for this sort of use case where there's a build command, there's an install command where you give it the destination directory, because in all these systems they usually have an empty directory you put all the stuff into, and then a way to run install check that could kind of put those things together and make it work effectively. So really to try to simplify what's required in order to do the builds through the packaging systems. Another member of the ecosystem are administrators. So what do DBAs need for extension distribution and management? Well, they need reliable sourcing. They need to know that extensions are coming from a place that they can depend upon. They need extension management so that for the systems that they manage, they can see what's installed, where it's installed, who has what, including some sort of inventory and auditing. If you maintain a lot of Postgres servers and you might have users installing extensions, to be able to run commands to say, okay, here's what you have here, here's what you have here, here's what you have here. So that you can find out when they have the illegal flying toasters extension that you can make them get rid of it. They need packaging choices and standardization, because a lot of in enterprise environments in particular, they will say, we only depend on this packaging repository or these subset of packaging repositories. They need to have options for that, for whatever those kind of choices may be. The ability to trust specific packaging sources and to build their own internal packaging options to overlay on top of that for stuff that's built internally, just for internal use. Other useful stuff are the mirroring and curation, mirroring so that you can have a local cached copy of stuff, and paths for upgrading extensions. So some things to thinking about for database administrators that we want to build to help integrate them into the system is extension management tooling for things like fast binary installation that requires no compilation, so they don't have to necessarily build their own packages. They don't necessarily have to install a compiler on their production servers. Or they can use the community binary packages directly, or the community OS packages if they are automating, having all the extensions they need, or not automating them. Or build their own packages to overlay on that top of them for stuff that isn't necessarily in a trusted source. They can say, okay, we trust our own internal one, we're vetting this small curated list of extensions, and we provide it there. Method of extension reporting, as I said, kind of audit what's on your systems. A registry access controls, what was I thinking there? The ability for, if you set up your own internal registry, to limit who can use it. And maybe something to simplify upgrades. The thing I think of is like, okay, give me a report of all the extensions installed here. Now replicate that and install them all on my upgraded new cluster I'm building over here. Something like that. There's more ideas that I think that can go into that. Binary registration federation, potentially. So if they're using, they can pull different requirements from different locations as they need them. Again, as I said, run their own registry and package their own extensions that are built by their own developers or curated ones that they pull in, and then gate it by authentication within their networks. And maybe they say, okay, we actually want to subscribe to a registry provided by some commercial entity that does some extra layer of security scanning not provided by the community stuff or something like that. That would be a useful option for them as well. The ability to mirror binary registries and have them close by so that things can be more efficient for doing the installs and builds when we need them. So I could think of a whole bunch of stuff for DBAs. So but let's look briefly at kind of an example of how I'm thinking we could do package management. There might be a package command for the command line client. They can say, okay, give me a list of all the packages, and they can say, okay, for this PGDG yum installation of 16.3, we have SciText, JSON-B, PL Perl, Unaccent, and Theory Semver extensions installed. So it's giving you a report. And one of the things that it can include in this report is, well, damn it. No, go back. There we go. Here it's saying, well, the latest version is 0.32.1 of this extension, but you currently only have 0.32.0 installed. So let's say they're using the community binary packaging we want to build out for the community. They could say, okay, upgrade this package, and what the client will do is it will find a binary for this operating system, Linux ARM64, this version of Postgres, version 16, and download that. And there's no compilation because this is a pre-built binary. It just has the .so file that it knows where to install because PGConf knows where to install stuff. It has the shared dir files for the control file, the SQL files that you need, and then also any documentation that's in there, and it knows where to install them. And this would be very, very quick, right? There's no time required other than downloading, unpacking, and putting the files in the right place. We want to support not only Linux, but also Mac OS, some flavors of BSD, and ideally Windows, and some extra comma in there, so there's probably other things in there I can think of. So now let's say they do a list command. This is similar to the list command we were doing previously as a user and showing, okay, look, now it's up to date. Great. But maybe they don't necessarily want to use the community binary distribution system for PGXN. Maybe they want to use a trusted registry. It'd be cool to be able to go look and say, okay, where are their binary packages for this system on the website? We can say, okay, this one is in the community Yum, the community Debian repositories, Trunk has it, Homebrew has it, Chocolatey has it for Windows, PGXN has it, whatever, right? So that you know where it's generally available. And if it's not available, maybe you know who to go talk to about maybe getting it added if you need that. So that's administrators. Another category, of course, is the end users, the people who actually use and build on the extensions. Now, what do they need? They need a reliable index of extensions, so they know there's one place to go to find the things that they need. They need effective search, so they actually can find it in those places. And I can do a whole rant on how poorly I implement PGXN search at some point. Curation and categorization, because very often they say, well, actually, I'm working on a data analytics problem. I only need to look at those to be able to browse for that. Quality signals, so when they're looking at something, they can say, oh, this looks like it's well maintained or well cared for, or oh, this one has there's missing some quality metrics that they can't, call it into question, the quality. The version support info, so when they're looking it up, they can say, okay, this one supports Postgres 13 through 16, but I'm using 12 and I'm upgrading to 17, so maybe you know then that it's not available for your use or not available yet. Quick and easy installation, because they just want to be able to download something, install it, and get started with it without this whole compile, install, configure, install process. And informative documentation to really help them understand what this extension is, what it's for, what the use cases are, how to use it, et cetera, et cetera, et cetera. So to meet the needs of users of extensions in the community, we want to build as the canonical registry for all the extensions in the system, of course, to enable that discovery through search, quality signals, category curation, links and easy installation instruction, which we kind of saw before with the screenshot from PGXN I showed earlier. Documentation, not only for the extensions themselves, but how to actually work with extensions in the broader ecosystem. So getting started with using extensions and how to use the community tooling to install them. And beautiful extension documentation in a centralized place, so it's easy to read up on them and understand it. A single line command to quickly and easily install extensions and fast binary installation without having to wait around for compiling and all that. Support for many platforms, because some of us are Mac OS, some of us are Windows, some of us are in ARM, some of us are AMD. Packages for managing multiple installations of Postgres, because some people use Yum, some people use Deb, some people use Alpine's thing, APK, some people use Homebrews, some people use PGM. It needs to not care so much about what those are, just be able to manage the extensions for any of them. OS packaging support, so that the extensions that need are available in the OS packaging systems that they tend to use. And for usage, to have good documentation to help them use it. And tested examples would be really cool. So when you're reading the documentation for an extension, you know that the example you're reading actually works. And then tutorials and references. Again, this is effort that extension authors ideally have to put in to make their extensions more valuable to users. But there are ways we can encourage that. So let's just look at some signal and installation stuff here. Let's say that I am using the command line client and I want to manage the schemas of my JSON for some way. So I do a search for JSON and it can return search results from the REST API for PGXN to show you what's available. And maybe for some level of signal, maybe we're depending on some sort of rating service where users have star-rated extensions. There are other ways we can build signals and include them in a client like this, as well as the web interface, but you can look at this and say, oh, okay, there was a recent release of this one and it has 4 stars. That looks pretty good. Let's go ahead and install it. So this again is just like we were showing for the DBA example earlier. We're just installing the extension. It is finding the community binary package for this OS, which is Darwin ARM 64 and Postgres 16, because we were managing this on PGM 16.3, which you can kind of see there on the top right. And as before, it just knows where to install the dynamic library. It knows where to install the control files and SQL files to get you going. And then you can list all the extensions that you currently have in your system. So that's users, a big one in the community. I had a long list there. The final kind of who is the ecosystem I think about is the industry many of us work in. So what do technology companies need? Well, first of all, they need to embrace and extend our stuff. And what that means is the ability to say, okay, we want to use the things that are made available by the community, but we are perhaps doing some curation of those products, or building our own sorts of products for rating them, or building reviews around them. Or as I said before, there's some sort of security scanning feature we provide and we do our own registry. And then when they do have these services they provide, that they actually are linked back when there's a trusted relationship to the root registry for the system. So in that one place where you know to go to find stuff, you know, oh, okay, this has been security scanned by this other thing, and if I pay for that service, I know I can use their thing, or thank you. Or whatever other features they can dream up to like improve on the extension experience for their customers. Of course, they need to be able to offer extensions for their customers and use the APIs that we have in the service for their database as a service products, for example. And another one I throw in here at the end is immutability. So often a lot of these companies are now running immutable images of Postgres for their systems. And so the extensions, which is dynamic per customer or per database, those need to be not immutable, so we need another volume to store them on, how to manage that. I'll be nagging Core about a patch for that in the fall, so you can ask me about that one later. But for the other stuff, let's look at how we could try to meet the needs of industry. They could build specialized registries from our registries to enhance them with additional stats, additional metadata, additional reports or signals. Security scanning, again, is the example I always like to cite. They could do, we would provide binary registration federation so that they could serve a subset of extensions for their own thing, but still have the ability to federate to other registries to pull down extensions to install. And they want to curate for their customers by copying only approved extensions from the registry, or rather than simply mirroring stuff, they're being picky about it. But they can use APIs to provide user experience for the users to actually install extensions without having to use that nasty CLI I was showing earlier, right? And then to be able to report back stats to the extent that they're trusted partners of the community and they have a desire and willingness to share stats, this can come back again to be aggregated to increase the signal for people. So let's say, for example, I just stole this example from the Tembo Cloud because I had easy access to it. But let's say I want to install Semver. You do a search for it and go there and just click install. And the beautiful thing is that this is actually using exactly the same APIs as the command line client I showed earlier. It's just they have the ability to build their own user experiences over it for the benefit of their customers. Which is what I said. Thank you, Keynote. So the vision here is to have features for a canonical source registry, search and discovery for all extensions, streaming and federation, streaming of releases and federation for multiple packaging systems, quality metrics and reports, binary packaging and distribution for multiple platforms and multiple Postgres versions, and simple installation and package management, right? So the architecture I'm envisioning to meet these needs is to have a root registry at the center where authors register and release their extensions. We have the website that is the one place to go for people to know to look things up. They have search, curation, docs, and download. They have the command line client that does much the same on the command. And these are very much based on what's in PGXN today. What's new is this idea of an interaction system which has things like it streams information about changes to the system, notably releases. It could have webhooks. It can notify downstreams. And it also has for trusted partners to write back, like, here's a badge for we tested on these systems, or reports for test matrices or reviews or what have you. These become part of the clients and reports. These are the stats and report systems that anybody can build for whatever need they have to build additional metadata for extensions to submit back through interaction system. And then they show up on the site as stats and links. 30 seconds. And then there's a binary packaging system which is alerted for new releases from interactions. It could download the sources from the source registry, use the client to build them and put it in its own binary registry, sends that information back to the root registry to appear on the website, and the CLI can be used to install these so it no longer needs to necessarily compile from source. So that's the vision I wanted to outline today. If you're interested in helping out or even just kibitzing or reading my crazy ideas, which I very much appreciate, here are a few links. These are mostly on the Postgres wiki. I have a bunch of stuff on my blog I've been writing on a lot since the beginning of the year. And I have, we do discussion in the community Slack, which you can link to here. And thank you for your time and attention.
Okay, the issue I have is more related to Postgresql itself than to PGXN. It's that a lot of things are, at least what I've done, is excluded from being an extension because it's just a shared library that you load into Postgresql, and that is out of extensions because you don't link it to a single database, you link it to a whole instance using shared payload libraries and stuff like that. And thus, I don't see the point in packaging it to PGXN since it's not an extension. You see, I use the makefile, the typical one, but I don't have any SQL line with it. I don't do it. It's not like an extension.
Using like the load command or something just for a library?
Yeah, well, it's for instance what has been done recently for pkg.go.dev to alter the search path to having it being notified to pkg.go.dev, stuff like that. It's just a shared payload library you had. That's not an extension. So do I put that into PGXN too?
Yes.
Okay.
Because I think we don't want to just say we support only create extensions. There are all sorts of ways to extend Postgres. And in addition to create extension or load commands for DSOs, there are also things you can use for hooks. There are things you can use for background workers. There are things you can use for foreign data wrappers use extensions. But also, like, you might just have a command-like utility. Like Mark Wong made a utility called pgtop. It's just pure C. It doesn't use any of the well, I guess it uses Postgres headers, so it knows what, but it's just reading the process table. That is something that is useful to Postgres developers and could be packaged up in a place where pgconfig's Bender option says, well, put it there, and then that's where it lives. It becomes part of your overall system. That's how I'm thinking of it.
Okay, well, thanks.
Yeah, thank you.
So now we'll thank our speaker for this very engaging talk.